Hello again, and in this video we will compare performance differences. The main point while we were doing all this way to implement KD3 and to check its correctness and so on. So let's go ahead and get started. To compare performance, we will need to call it again in update function. But before calling in update function, we will need to actually comment out these debug statements, because it will be spamming out at each update, and we don't want that. Actually, we can leave this debug statement because it doesn't matter. It's in a starting function, and then we can we will go into update function. We need to have something what we can use to switch between one method and another. The easy way to do that is to use input, something like input. So we can write what we can write. We can write if input dot get actually yes, get key down, and which key we want to use, probably let's say A. Okay, let's check if I am not messing up something. It's correct. Okay, that's nice. Okay, so now here we can put some boolean values. Let's say bool use KD equals false. By default, we don't want to use KD3, yes? And when we press A, we can switch between them. So what would that be? So if we want to switch, we just type the bool and type not equals to this one, yes, because it switches. So if it was false, then it becomes true. If it's true, then it becomes false. It becomes exactly the opposite. Now we can call here if not for, if use KD equals false, then call regular nearest neighbors. Else, let's else call this one. So we did a small thing. We declared a boolean value which can be switched by pressing a key in a keyboard, and this boolean value is being used to check which method we are using to find our nearest neighbors. So okay, something goes wrong. If not equal, probably that way. Yes, not equal is when you're comparing in the if statement. For example, here equal equal, then you type, for example, it would be like that. But when you assigning it to the value, you type equals not the value, the original value. Okay, let's go ahead and to try to test it, how it works. So to click run, firstly we want to have this 1000. Yes. If I click run, I should get back to 10 frames per second. If I click A, it brings back to KD3, and we can see how much performance gain we have. We have about 60 FPS. It means that all these nearest neighbors are being found correctly, and we are running 1000 points with their nearest neighbors on each update at around 60 or 70 FPS rates. So that's a huge boost in performance. That's how all these neighborhood checks are working. This is why we have in engines such things as collision tests and large number of objects possible to define their collisions and so on. So neighbors, to find neighbors can be a little bit tricky, but there are ways such as KD3s which improves this performance quite a lot. So these tutorials were covering mostly about how to find nearest neighbors and how to do a simplest changes on how to improve the efficiency to bring hundreds or thousands of objects or checks of proximities in a very seamless way. So that concludes our series. Thanks for watching, and hope to see you in next exciting topics where we will start to apply these neighborhood checks.